Hello my dear students, in this lecture we are going to see one previous year GATE numerical on eccentrically loaded bolted joints. This question was asked in GATE 2015, GATE 2015 for 2 marks. Now the question is here, a cantilever bracket is bolted to a column using 3 M12 into 1.75 bolts. Now here M12 into 1.75 bolts means here diameter of bolt is 12 mm and pitch of bolt is 1.75 mm, and it is a metric thread, and there are 3 bolts PQR. Here PQR, these 3 bolts are given. The value of maximum shear stress developed in bolt P in MPa is. Now in bolt P, what is the maximum shear stress? That is where the question is to find shear stress in bolt P is equal to question mark, and that we have to find in MPa, that is Newton per mm square. MPa means Newton per mm square, right? Now let us solve this question. Let us observe this question. Here can I say bolt PQR are given, and these bolts are at eccentricity of 250 mm from the applied load, right? Here applied load P is nothing but 9 kilonewton, where this P is at eccentricity of 250 mm, right? All dimensions are in mm. Here somewhere mentioned all dimensions are in mm. Now can I say for PQR, the centroid of these 3 bolts will be at Q. This G is the centroid of all the 3 bolts. At G is nothing but at Q location, and from Q the distance of P is 30 mm, and from Q the distance of R is 30 mm. That means we can say here RP, that is distance of P from G, RP is 30 mm, as well as RR, that is distance of R from the G is 30 mm, right? Similarly, the Q and G coincide, therefore radius of Q will be 0. Radius of Q will be 0, right? These data you can say here. Now let us solve this question. The 3 bolts are given like this. The bolt P, after bolt P there is a bolt Q, after bolt Q there is a bolt R, right? And therefore the CG of or centroid of all these bolts will be at Q, that is G point. Now at again the distance of P from G, this is called RP, right? This RP is given 30 mm, and distance of R from G is RR, which is nothing but again 30 mm. Now if you see the diagram, in diagram you will find that the load P is acting at some eccentricity of E. Therefore this load we can transfer at any location along with moment. Therefore if I want to put this force of 9 kilonewton at G, then I can put as it is. See here, this 9 kilonewton I can put as it is, but along with this 9 kilonewton I have to transfer the moment created by this 9 kilonewton about this G point, which is nothing but 9 into eccentricity is 250 mm in clockwise direction. Therefore there will be a moment about G which is called torque, and this torque will be equal to P into E, which is nothing but 9 into 250. 9 is in kilonewton, 250 is in mm, kilonewton mm. This is the moment acting at point G, right? Therefore come to the diagram. At G, 9 kilonewton is acting in vertically downward direction, which is nothing but P is equal to 9 kilonewton, right? As well as there is a torque which is acting in clockwise direction. This torque is nothing but 9 into 250 kilonewton meter. Now my dear students, we know that to balance this 9 kilonewton there will be a primary shear in bolt R, Q and as well as P, and which is nothing but opposite to this 9 kilonewton which is acting in downward direction. Therefore there will be primary shear in bolt R, which is of magnitude will be PSR. Again there will be a primary shear load in Q, which is nothing but PSQ. Again there will be primary shear load in P, which is nothing but PSP, right? And we know that the primary shear load is equally distributed in all the bolts, that is PSR is equal to PSQ is equal to PSP, that is primary shear load is equal to total load divided by number of bolts are 3, which is nothing but 9 divided by 3, which is nothing but 3 kilonewton. Therefore primary shear load in all the bolts is 3 kilonewton. Now as there is a torque which is acting in clockwise direction of 9 into 250 kilonewton mm, here it is a mm, you can say it is a mm, kilonewton mm, right? Therefore to balance this clockwise torque we need to apply anti-clockwise torque, therefore for secondary shear on R there will be an anti-clockwise torque about G, which is nothing but secondary shear load, that is PSR dash, as well as on P there will be a secondary shear load in which will cause anti-clockwise torque, which is nothing but PSP dash, right? Now see, always the radius and secondary shear load are perpendicular to each other. Here the radius and secondary shear load are perpendicular to each other because it is a torque. Torque is nothing but force into perpendicular radius. They are creating torque, right? To balance this clockwise torque there will be an anti-clockwise torque, right? Now we know that the secondary shear load, let us say PSR dash, is nothing but K into radius of R. It is nothing but K into radius of R, and K is nothing but P into E divided by radius of R square plus radius of Q square plus radius of P square into radius of R, right? Now already we have seen the radius, therefore PSR dash is equal to P is nothing but 9 kilonewton into eccentricity is nothing but 250 mm, right? Into radius of R we know that 30 divided by radius of R is 30 square plus radius of Q is 0 plus radius of P is 30 square, right? Now let us solve this equation. You will find this is equal to 37.5 kilonewton. This will be the secondary shear load on bolt R. Similarly we can find in other bolts. Now see, if I want to find in P, then I can say PSP dash, that is secondary shear load in on load P is K into radius of P. Now see, radius of P is nothing but radius of R. Therefore I can say write like K into radius of R. Therefore it is equal to PSR dash. Therefore secondary shear load in P is equal to secondary shear load in R, which is nothing but 37.5 kilonewton. This we can say. Again, if I want to find in Q bolt, let us find in Q bolt secondary shear load in Q bolt. Therefore secondary shear load in Q bolt, that is PSQ dash is equal to K into RQ, radius of Q. Radius of Q is 0, which is nothing but 0 kilonewton, right? This is how we have calculated all primary and secondary shear loads, right? Now let us write them. Now all primary and secondary shear loads we will write here. Primary shear load in all bolts is PSR is equal to PSQ is equal to PSP is equal to 3 kilonewton, that we have calculated. Again secondary shear load in PS, that is secondary shear load is represented by PS dash, PSR dash is equal to PSP dash is equal to, we have calculated 37.5 kilonewton, and secondary shear load, that is PSQ dash is 0, right, kilonewton. Now question is to find maximum shear stress in load P. Question is to find maximum shear stress in load P on bolt P. There is primary shear load as well as secondary shear load. Therefore consider bolt P. If I consider bolt P, the question is to find the maximum shear stress on bolt P. Therefore consider bolt P. Now on this bolt P there is PSP acting in vertical direction, which is nothing but 3 kilonewton, that is primary shear load, and there is secondary shear load acting towards left, which is nothing but PSP dash, which is nothing but 37.5. Now angle between them is 90 degree. right? Therefore, if I want to find resultant of them the resultant on load P on bolt P will be force on P, that is shear force, total shear force on P. Therefore, resultant will be total shear force on P will be equal to under root of PSP square plus PSP dash square. Therefore, total load on P will be equal to under root of 3 square plus 37.5 square, which you will find answer as, this answer will be 37.6198 kilonewton. This will be the answer, right? Now it can be also written as is equal to 37.6198 into 10 to the power 3 Newton in terms of Newton, right? And the question is to find shear stress in P, which will be equal to force in P, total force in P divided by area, which is nothing but equal to force in P divided by area is pi by 4 d square, and diameter is given 12 mm. Therefore, put the values. Therefore, shear stress in P is equal to 37.6198 into 10 to the power 3 divided by pi by 4 into 12 square, diameter is given 12, and if I solve this I will get answer 332.63 MPa. MPa is nothing but Newton per mm square, because all force we are using in Newton and dimensions we are using in mm. Therefore, it is nothing but Newton per mm square, which is nothing but megapascal. Therefore, answer is 332.63 megapascal. Thank you, dear students. In next lecture, we will see one more numerical on bolted joint design.